Let's look at some common caching strategies that we have. But before that, if you don't know what caching is, in short, if I want to explain, let's say we want some data from our application, but to normally retrieve the data, to query the data in our main database, it requires a lot of time and it requires a much greater amount of time. So we send a query, then it searches for the data and returns it to the user. Let's say it takes 200 milliseconds of time, just for example. But in some scenarios, we need some very fast retrieval of data. And let's say we cannot wait for 200 milliseconds to retrieve our data from the database. In those applications, we have something known as a cache memory. In cache memory, what happens is basically we store the data in key value pairs, and the data from cache memory has a very fast retrieval. So whenever we need very frequently accessible data, like a data which is frequently requested from the user, the data is usually stored in the cache memory, and from the cache memory, the data is retrieved in a very faster manner as compared to normal queries in our database. So cache memory basically optimizes the time to fetch hot data from our application. So it is basically used to store hot data or the type of information which is frequently requested from our client, so that we do not have to query our database again and again and wait for a longer period of time. And these are the main caching strategies that we have. So the first is read through cache, then we have write through cache, then write around cache and write back cache. So let's get started with the first one, which is read through cache. Now, in this read through cache strategy, what happens is, let's say we have a user right here. Then we have our cache memory. Here we are using Redis for our caching, for example. And then we have our main database. So we have this structure, let's say. And according to read through cache strategy, what happens is whenever we need to fetch some data from our application, or whenever we need to basically read some data from our application, we first read our data through the cache memory that we have. So whenever a read request comes into our application, we first read it through the cache memory that we have. And only if we do not have the data in the cache memory, then we go to our database and query for the data in our main database that we have. So whenever we need to extract some information or read some information from our database or like from our application, then we read it through cache first, and if it is present in the cache memory, then it will be very retrieved in a very fast manner and returned to the user. But let's say if the data was not present, then we will query our database, and then it will take the normal database response time, like the normal query response time, and the data from the database will be returned to the user. And then we also store the data which we retrieve from the database in our Redis or like in our cache storage, so that whenever the user comes and makes the request for this same data again, then that same type of data can be accessed through this cache storage that we have. So whenever a read request comes, we read it through our cache. If the data is found, we return the data. If it is not found, we go to our database, get the data from there, return it to the user, and store the data in cache for future purpose, so that whenever the user comes again, it can be given to the user in a faster manner. Now, this strategy is very similar to lazy loading, because in lazy loading also we use this kind of strategy where we read through cache first, and then if it is not found in cache, we store it in our we query it in our DB, and like we only store only those information which got a cache miss. Basically, in our Redis or in our cache memory, we only store the information which is required by the user frequently. So we are not storing anything redundant or extra in our cache memory. So it is a very optimal method for our cache storage. Next, we have the write through cache strategy. Now, in write through cache strategy, what happens is, so in write through cache strategy, what happens is whenever we need to write any data, or whenever we need to like put some data in our application, we always write first into our cache memory directly. And then the cache memory updates the data into our like the cache memory then updates our database with the data that we stored in cache. So whenever we need to write something or write some data in our application, we write it to the cache first, and the cache then synchronously updates the database with the data that we have written in the cache. So basically, this is known as write through cache, and from the name itself, we can see that we are first writing in cache memory. That is what is known as write through cache. So we are going to DT, we are writing in DB through our cache memory, which is why it is known as write through cache. And from this, we can say, like from this strategy, we can say that let's say if we have a stock market application. In a stock market application, basically the prices of stocks change in every second or like every half a second, right? So we need to have the latest information every single time. And if we write in our database first and then cache it to our cache and then get it from the cache, it will take a much longer time. But if we write in our cache memory directly and then whatever data we require, we get from the cache memory directly, then it will be a much faster process. So this write through cache strategy is useful in areas where we require quick retrieval of the latest information because we are writing the latest information in the cache directly, right? So the latest information is available for fast retrieval. So it is used in applications where we need very fast, like quick retrieval of latest information, like stock market application, as I mentioned. Then we have the third strategy, which is known as write around cache. So the third strategy that we have is write around cache. And in this strategy, what we do is whenever we need to write any data in our application, we write it directly to our database. So this time we are not writing directly to our cache memory, we are writing the data in our database. So whenever we need to write or put some data in an application, we do it normally like we do. That is, we directly write it in our database. And then whenever we need to retrieve our information, we read it through our cache. So whenever we read, so let's say the write operations that we do are directly done in the database and the read operations are done through the cache memory. So of course, from this you can see that if we write something in our database and then try to read it from our cache, of course, at the first try, it will not be available in our cache memory, right? So for the first read that we do in our cache storage, we basically get a cache miss because we do not have the data in our cache memory yet. But after we get a cache miss, the data gets updated into the cache, and then from the second or the subsequent reading onwards, we get the data in cache, and then we start to get cache hits. So in write around cache, the first read request or the first read that we perform has a cache miss and therefore takes a longer time than usual. But like in this case, we can see that the first read request or the first read that we do will not have a cache miss because every data that we are writing is present in the cache. So we cannot have a cache miss here. Like we generally do not have a cache miss here because we are writing every data in the cache. So whenever we try to retrieve our data that we wrote, we get it directly from our cache. So we do not have a cache miss generally here. Then we have the fourth kind of strategy, which is write back cache, or it is also known as write behind cache. Now, in this fourth strategy, what we do is whenever we need to write data into our application, we do it in our cache memory. So whenever we need to write some data in our application, we do it in our cache memory. But you may think that it is similar to write like write through cache, right? Here also we are whenever we need to write some data, we are writing in our cache memory and then the cache updates the DB. Here also we are writing in our cache memory first and then the cache updates the DB. But the major difference is the process how the cache updates the DB. Here the process by which the cache is updating the database is a synchronous process. So it happens one by one, that is like in synchronization. It is a synchronized process or an async process. But here, the database updating process is an async process. So we write in our cache normally, and the cache is responsible for updating the DB, but it updates the DB in background in an async job. So basically, because of this, we get a very high advantage in areas where we need to constantly write in our cache. This is because, let's say, we constantly need to keep writing in our cache or like keep putting data in our cache. If it had been a synchronized process, then every time we would have to first wait for the cache to write it in our DB, and then we get an OK response that okay, the database has been updated. Now we can do the next write operation. So it would have if we it would have made us wait before we could do our next write operation. But if we had to do write operations very rigorously, then it would not have been ideal for us because it would have made us wait for the next write operation. So because it is an async process, we can do multiple write operations simultaneously and we do not have to wait to get a response from this. It can run in the background and it can update the database later on while we are still writing more amount of data in our cache memory. So we can keep on writing in our cache memory and it will keep on updating in an async manner in the background basically. And we do not have to wait for each response to get completed or each request or updation to get completed and then move on to the next one. So this is basically very useful in cases where we have a very where we have a very high write traffic when we need to write constantly in our cache memory. So we don't have to wait here in this case right here. We can keep on writing and this will keep on updating in the background. But it has its disadvantage as well. Like since we are updating it in an async manner, let's say we queried our data from the database. Then let's say while we queried our data, the database at that time did not get updated yet. So while we, let's say, queried our data, the database by that time still did not get updated with the latest value. So what we will get basically is stale data at that time, which has not been updated yet. So we have some consistency issues, like we do not get consistent data. We have some inconsistencies in the data that we get, but it is a trade-off for this async operation that we have here because since we have multiple write operations that can take place at the like without waiting for the operation to be completed, it is a trade-off that we need to do. So we are prioritizing speed over consistency in this case. So these were the basic four caching strategies that we have. And through these by applying these and by like it depends on our application which caching strategy we need to use, and each has its own trade-offs and own use cases.